Hi, so in this tutorial, we're going to look at how to differentiate functions. So in differentiation, we know that it tells us the rate of change or how something is changing, how fast or how slow something is changing. So if you're given a function, let's say f of x is equal to, let's say, a to this. So let's say this is a function where we have a to x exponent n, and x is the variable. We're going to say that the differential of f or f prime of x is going to be, we just multiply a by n and reduce the power by 1. So that is basically what we are doing in this particular video. Differentiation is not difficult, but the only part that becomes difficult is if you have implicit differentiation, maybe if there is quotient rule, or maybe there's product rule. That's basically sometimes the problem, but if not that, I think differentiation is not a problem at all. So let's take a question. Let's say you have f of x to be equal to, let's say, x squared. So the differential of this, we know that our a is 1, our n is 2. So all that we need to do is multiply a by n, and a by n means 1 multiplying by 2. Then we keep the variable, then we're going to reduce the power by 1. So we're going to have 2x to the exponent of 1, but we don't need to write the 1. So it means that f prime of x is going to be what? 2x. So that is it. Now let's take another example. So let's see if you have f of x is equal to, let's say, 5x cubed. We know that this is going to be our a, this is going to be our n. We multiply the n by the a, we are going to get 15. So that will be 15x. Then we reduce the power by 1. So 3 minus 1 gives us 2. So this becomes f prime. So f prime of x, or the differential of the function x, going to be 15x squared. Basically, that's what we are doing. Very simple. Now, what if you have a longer function? Let's say you have something like this. F of x is equal to, let's say, 3x to the power of 4 minus 2x to the power of 2 plus, let's say, 7. How do you differentiate this? Like we said, this becomes our n, this becomes our a. So f prime of x will be 4 multiplied by 3. That gives us what? That's 12x. Then we reduce the power by 1 and we get 3. Now 2 multiplied by 2 gives us 4. X, we reduce the power by 1 and then we get 1. Now the differential of any constant is 0. The reason is that there is no, from our rule, we saw that we need to multiply the n by a, and from here we can see that there is no n. Okay, so n is basically 0, or we can just say x to the power of 0. 0 times that gives you 0, reduce the power. So basically everything becomes 0. I hope you understand the reason why the differential of a constant gives you 0. Because if we have this is our n, this is our a. When you multiply n by a, you're going to get 0. So basically it cancels out, and then this becomes our f prime of x. That becomes the derivative of the function. Let's take another example. Let's take f of x being equal to, let's say 2x minus 1, then x plus 3. So what we can do is that we can decide to use a product rule, or we can expand. But because I don't want to dive into the product rule, maybe I'll do that in the next video, or maybe if somebody have a special request, you can leave it in the comment section. Then I'll look at that request, and based on that I can make a good video for you. Okay, so let's use the expanded form. Let's expand this. So to expand this function, what we do is that we take the first term, multiply by the x plus 3. Then we take the negative 1, multiply by the x plus 3. So you take this, multiply by everything here, take this, multiply by everything here. So it becomes something like this multiplies this, and the same thing multiplies the second term. Take the next number, multiply by this, it multiplies that. All right, so when we multiply, we're going to have this multiplied that we get 2x squared. Then this multiplies that, we get positive 6x. Then we get negative x. Then we get negative 3. So now we're going to differentiate this. Okay, we can even operate on that. So we're going to have 2x squared. Then we have plus positive 5x minus 3. So this is the function that we're going to differentiate. That's not the derivative. We are trying to expand the bracket so that we can get the actual function. Then from there we can differentiate them. So f prime of x becomes, we multiply the exponent by the coefficient of the variable. We're going to give us 4x. Reduce the power by 1, so we get power of 1, plus, then there's an exponent of 1 here. 1 times 5 is still 5. Reduce the power by 1, we get x to the power of 0, and any number to the power of 0 is 1, so it's gone. Negative 3, when we differentiate negative 3, which is a constant without a variable, it becomes 0, so the answer becomes 4x plus 5. Right, we have one more question to go, then we can call it the end. So that if you have any problem, please you leave it in the comment section, then I will gladly assist you. Just in case you have any problem, or maybe you want me to make a special video, I will do it for you. So just leave it in the comment section.